integration on chapter 1. That is application of first order differential equation in electrical circuit system. Based on the question given, with the RL circuit in the series, the question given ET value, L value and R value. The equation asks us to prove this equation from circuit by using the Kirchhoff voltage law. So first step, by applying KVL, we get the equation that is negative ET plus VL plus VR equal to 0. By transferring the negative side to other side, we get VL plus VR equal to ET. So for the inductance, for VL, it was L di over dt R plus IR equal to ET. The next step is substitute the value of ET, L and R into this equation. So by substitute the value L 0.02, R 4 and ET is 80 since 400 T. So to get same equation with this, we divided the equation with 0.02. So the last equation we can get is the I over dt plus 200I equal to 4000 sin 400 T. So that's all from me. Thank you.
So here we have a circuit, a parallel circuit, which contains 3 loads, 2 Henry inductor, 5 ohm resistor and 1 Henry inductor. So first of all, the first question is, we have to prove that this circuit will give this type of equation. So what we can do the KVL on the left side. So E is equal to inductor voltage plus resistor voltage, and then so we can get 10 is equal to LD I1 over dt plus R I1 minus I2. Okay, so we will get the first equation, which is 10 is equal to 2 di1 over dt plus 5 multiplied with I1 minus I2. That is the first equation. So second one, we will do KVL on the right side. So VR is equal to VL, R I1 minus I2 is equal to L di2 over dt. Why I2? Because it is the current number 2. So the second equation can be simplified from this equation. We can get I1 is equal to 1 over 5 di2 over dt plus I2. That is the second equation. The third equation, we will differentiate the second equation and we will get di1 over dt 1 over 5 d2 I2 over dt2 plus di2 over dt. That is the third equation. So how we gonna solve it so that we can get a simple basic equation? So we gonna use 2 and 3 equation and we substitute 2 and 3 in 1. We can simplify it to 10 is equal to 2 over 5 d2I over dt2 plus 3 di2 over dt. So it can be proved that the circuit can give this type of equation. So next, we continue with trying to solve so that we can get I2. So from this general equation, we can equal it to 0 so that we can get M from the equation. So after that, we will get M1 is equal to 0 and M2 is equal to negative 7.5T. Okay, so negative 0.75 only. So we can get that it from the second rule, I think, that it is not the same, the M value is not the same. So case 2, IC2 is equal to AE 0 plus BE negative 7.5T. So in the conclusion, we can get IC2 is A plus BE negative 7.5T. Okay, that is for the homogeneous equation. For the non-homogeneous, we will need to find IP2. So IP2 need to be different from IC2 formation. So IP2 C is same like A, so we can't use this. So we multiply it with T. So CT is not have the same form from the IC. So so the IP2 is CT. So we differentiate IP2 to first derivative and second derivative. IP2 for the first derivative we will get C, and IP2 for the second derivative we will get 0. So then we will get from this one. From this equation, we will use the d2I1 over dt2 as IP2 second derivative plus 3 IP2 first derivative. So we will get 3C. So we will need to compare 3C with the answer of the general equation, which is 10, to get C is equal to 10 over 3. So we refer to the IP again, IP2 again. IP2 is CT, so 10 over 3 multiplied with T. So that is IP2. So to get the equation of I2, we have to add IP2 plus IC2. So A plus BE negative 7.5T plus 10 over 3T. That is for I2. And I2, after we have simplified all of the things, we can get A plus BE negative 7.5T plus 10 over 3T. And we differentiate the I2, so we can get dI2 over dt is equal to negative 7.5 BE negative 7.5T plus 10 over 3. So that is the equation for number 4 and 5. So to solve I1 or to get I1, we need to substitute the equation from 4 and 5 to equation number 2. So after we have simplified all of the equation, we can get that I1 is equal to A plus 2 over 3 minus 1 over 2 BE negative 7.5T plus 10 over 3. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Nabilah Binti Khalid, and today I will be presenting from chapter 3, and I'll choose question number 1. And the question is asked to prove that this two-loop system can be governed by this equation. So for the first step is to find the KVL for the left side of the circuit. So first from the equation, simplify from the loop 1 is 12 equal to L d1 per dt plus R multiplied by Iy minus I2. So when simplify this equation, it become differentiate of I1 is equal to negative 5I1 plus 5I2 plus 12. Now this is for the loop I1, and next is for loop I2. For the loop I2 is resistor 1 multiplied by I1 minus I2 equal to I per C. Integrate, differentiate I2 plus I2R. So when we simplify the equation, lastly we can simplify until here. Then from this equation, from this equation, differentiate it, so there is differentiate of current 1. So to eliminate the differentiate current 1, we substitute this equation into this equation so that there will be no differentiate of I1. When simplify the equation, the simplified equation is dI2 per dt is equal to negative 5 over 3 I1 plus 23 per 15 I2 plus 4. So from these two equations, we can form a metric form like this expression. Differentiate of I1 and differentiate of I2 is equal to negative 5 negative 5 over 3 and 23 over 15 plus 12 and 4. So from this metric, following the non-homogeneous system of first order differential equation, we can form this equation, and therefore the equation is proven to be, this circuit is proven to be true for this metric in this metric form. Okay, that's all from me. Thank you.
Assalamualaikum, I'm Elyana. We present chapter 4, application in Laplace transform in electrical circuit system. Okay, from the circuit, we know the value of resistor is 12 ohms, inductor 4 Henry, and voltage source is 24 volt. Using KVL law, so voltage drop resistor plus voltage drop inductor equal to voltage source. 12 IT plus 4 di per dt equal to 24. So we using Laplace transform, 12 Laplace IT plus 4 Laplace di per dt equal Laplace 24. So we get 4s is minus 4 plus 12 is equal 24 over s. So we simplify the equation, we get is equal to 24 over s plus 4 over 4s plus 12. Next, we use partial fraction to solve 24 over s in bracket 4s plus 12 to find the value of a and b. So we write a over s plus b over 4s plus 12. To get the value of a and b, we assume s equal to 0 and s equal to 1. When s equal to 0, we get a equal to 2. And when s equal to 1, we get b equal to negative a. So we rearrange the equation. We get 2 over s minus 8 over 4s plus 12 plus 4 over 4s plus 12. We simplify, we get 2 over s minus 4 over 4s plus 12. Then we simplify again the equation 4 over 4s plus 12. We get 2 over s minus 1 over s plus 3. To find the value of current, we use inverse Laplace. So we inverse Laplace the equation. We got 2 minus exponent the power of negative 3 times 3t a from here.